Oh, gosh, there's a chair there.
Looks like someone's stuck in there.
It's quite all right. I'm actually fine. Thank you.
Okay.
Expect a discount next year, though.
Evidence suggests you won't be disappointed. Yeah, so always good to see repeat attendees. Always an honor. So, great. So we're going to go through a whirlwind set of different items today that I consider pretty essential. And we'll see how far we get, and we'll continue on some next time. So one thing I wanted to do is finish up a few things from last time about Java statements. I had let you go catch the bus and promised a few pieces of information additionally on statements. You recall that statements are, what is a statement? It's a request to Java to what? It's an action, to do something. It's a command. And where are statements often found? We can roll in another one if you'd like.
I'm waiting for Dylan to be free, so I'm going to go in and out.
Oh, I see. Okay, yeah. Yeah, I sympathize. So a statement, where are statements found a lot in AnyLogic? You remember? Yeah, and actions. So it may be an action associated with entry and exit of a state. It may be an action associated with a transition. Where else might we find actions? Well, associated with events, right? Events, fire. And their job in life is to perform some action on some schedule. And there's a thing called a dynamic event, which you can sort of create however many you want, and they're kind of like a timer which will go off and perform some action in the future. So when a deer mates, you might create a dynamic event to go off to give birth to the baby deer in another, 6 months, Cheryl? 9 months?
That's a good question.
Yeah.
4.5 comes to mind, but I could be wrong.
Okay. Cheryl's in large animal clinical sciences.
But not deer clinical sciences.
Not deer clinical sciences. Yeah, indeed. Okay, so yesterday we talked about a bunch of types of statements, and presciently because we saw a bunch of them today. But there are some I did not talk about yesterday. We did see composite statements, these ones in curly brackets. Do you remember that? Mm-hmm. We actually needed to put curly brackets around inside that for statement for it to contain those two substatements. Dylan, had you put in some curly brackets? And we noted some expressions or statements, but there are these ones, try, catch, finally, and throw an exception that are worth knowing. Any questions about sort of loops or if statements and switch statements, which I did mention yesterday? Any questions about them before we talk about these types I didn't talk about? Yes?
Could you just review the switch statement again?
Sure.
I don't think it's stuck.
Sure. The switch statement basically allows you the same functionality as you could accomplish through a bunch of if-else. So if it's this one, do this. If it's that one, do that. If it's the third one, do this third thing. It's kind of like many branches, yeah. So it can handle many possibilities in kind of a structured way.
Mutually exclusive.
Typically mutually exclusive, although there's this awkward thing that they can fall through and sort of combine their actions, which is generally frowned upon because it's obscure. But generally speaking, they're mutually exclusive, so you have one case to handle, case one, case two. But what you can do also is you can actually have several in a row that all have the same handler here, actually. So you could say, like, for case 0, 1, 2, and 3, do these things. For case 4 and 5, do this other thing. And it allows you to kind of handle a bunch of possibilities in a compact form, especially where there's overlap between them. It's particularly, between what you have to do for several of them, it's particularly convenient.
So if you were to have, say, 3 things that were having the same action.
Yeah.
Would you list case this, case
Case
that?
colon, case colon, case colon, just
Okay,
like that.
And then
yeah.
give the action.
Yeah.
That makes sense.
Yeah.
Okay.
Yeah, but the thing you have to watch out for is, what that counts on is sort of, first one we handle will just fall through to the next thing. And so there's kind of this weird fall through rule where if you don't have a break at the end of one, it will fall through to the next. And there's some things with loops I didn't talk about with breaks and continues. There are these special words, break, which means basically break out of the loop at a certain point or continue on to the next iteration of the loop without doing anything more. Those are actually used in loop context as well, but here it means basically break out of this and go to the end of the whole statement. You could have a default case that handles everything else, and often generally you want that because if there's some unexpected value you want to know about it.
So because of the fall through or the breakout patterning, is there an efficiency gain to thinking in terms of the relative frequency of either the cases that you're going to be handling or the ifs that you say if this, then do this processing and then break out of this loop if it's true, or go to the next else?
Yeah.
Do you understand the question?
Yeah, I understand the question. I'm an old compiler hacker, and the time was I took delight in strategies which would optimize the timing for these sort of things. Good friend of mine wrote the switch and case handler for the Microsoft compiler. She now works for Google, but I helped strategize with her about ways to optimize the handling of this. Generally speaking, though, the savings tend to be pretty modest. Compilers are really sharp about how to sort of jump accordingly in clever ways. And with if statements, it's slightly more efficient to put the most common case first, but I wouldn't go overboard with it. It's just a slight performance advantage. Okay, we're welcome to bring in more chairs from the neighboring room, S311, if you'd like to do so. So I would say it's these days it's
May not be.
pretty minor stuff, unless you have many items there and it's an overwhelming frequency of the first one, something along those lines. Generally speaking, a lot of the Java code will be slower for other reasons than the micro details of this. There's things having to do with animation and stuff like that, and it's not worth really worrying too much about this sort of stuff. It's broader issues. Yeah, so within a loop, you can have break statements, and those will mean it'll actually break out of the loop. It'll stop the loop if you have a break in a loop. Or you can have a continue statement, and that means basically immediately go to the top of the loop again, which are useful constructs. So that was the switch statement. Was that helpful in terms of some of the features? Okay. Glad that's useful. One reason for a composite statement, one reason for the statement where you might have if, this condition, if age is less than 18 or something like that. One reason you have a set of curly brackets, or what Dylan called squiggly brackets, is you might have several lines, several commands in here, several statements in here. But another reason is you want to declare a variable in here. You want to declare, int age of mother equals, this dot mother dot age or something like that, and then use this age of mother at several places here, age of mother. The point is that within a composite statement, we can insert a variable declaration sort of very conveniently that only lives in here. It's only known, only seen in here. Doesn't clutter up things elsewhere. So we'll often have that sort of pattern where we have a block, and then inside of it we have variables declared, which can be used then nicely to use this value. Is that meaningful to people? Okay. Right. So variable declarations are associated. I'm going to be going after it with this, but this is an example of a variable declaration, right? Okay. I want to talk though about about this uncomfortable case. There's an uncomfortable case called an exception. Generally speaking, functions, for example, return values. But it turns out that things can go wrong. Things can happen, like a file that you asked to be open might not be found. Or it might be asked to write out some data to a disk and it's full. Or it might be asked to read data in from a database and it can't connect to the database. Or to write data to a database, it can't connect to it. It might be asked to get input from the user on like what's the age group on which to intervene, perform vaccination, and the user enters something nonsensical I can't understand. It enters A for the age group. I don't know what that is. In these cases, we basically Java code does it calls what's called signaling an exception. It throws an exception, and this again is a sort of bit of terminology that's just so common in computer science that people forget that other people don't know it. So we say, oh, this code threw an exception. And AnyLogic will throw exceptions for you. The reason I'm trying to tell you is because I'm trying to get you useful things for running AnyLogic models, and you will see exceptions sometimes be thrown. The most common one is something called a null pointer exception, or null reference exception. Have you ever seen that? Yeah.
Yeah, we just got that. We're putting a GIS map, I think, in where map used to be kind of.
Right. And
We didn't like it very much.
it doesn't surprise me. You know, let's go create a null pointer exception. Would you mind if I do it? Is that okay?
Great.
Okay. Great. I'm gonna create a kind of singularly boring one, I think. Here, what I'll do is this. I'm gonna put in a parameter called mother into my agent. And this will be of what sort of type? Person? Yeah? Okay. All sorts of things are happening. Person here, right? Hey, boom, yeah. And if I don't refer to anything on it, it'll be by default null. Okay. So maybe I forget to set it, and I'm going to have the action to this. I'm going to say trace ln. My mother's name is mother, okay? But I'm going to forget to set it. We have orphans throughout this. Not a single one actually has a mother yet because we haven't set it. We could, but we haven't set it yet. So if I ran this, it would be an unhappy. Oh, look at that. So actually, oh my gosh, my mother's name is null. Yeah, okay, it didn't actually throw it. Okay, well, fine. Watch this. My mother's name's length. Sorry, I was not thinking well. Yes, so mother is null here. It doesn't refer to anything. Okay, so let's do mother.name or income. My mother's income is such and such, right? I can print out null, that's fine, the mother is null, but if I try to find her income, now I'm asking for the income for something that doesn't have a referent. And look at that, null pointer exception, there we go. So it's kind of like, I don't know, it would be kind of like if you said, gosh, I'm trying to think. Does the School of Public Health have a formal director now? Has that been settled? It's not just an interim director.
Well, it's interim.
Okay, so I could ask Cheryl, give me the last name of the director of the School of Public Health. Cheryl, you need to give me the last name of the director of the School of Public Health. And Cheryl would, there is no last name. There's no director right now. There's just an acting director. I say, well, it needs to be the director. And she'd say, well, tough luck. and she could recently throw a null pointer exception. She could throw it at me.
Throw it at you.
So this is an indication, you know, there's something that it should refer to something, but it's not. Should refer to some particular person, but it's not. We're asking for the income of someone who doesn't exist, someone that is not known. So it throws what's called a null pointer exception. Now, one of the reasons I'm telling you this is because this, first of all, you can expect this, and it's an indication of a bug, typically, a defect in your code somewhere. Something is wrong. Typically, there's something that should be initialized, meaning it should have been set up, but it wasn't. And you get this. So let's go. Press OK. Actually, we don't even have to press OK. But if we go over here, what we'll see is there's actually more information it provides you. And I don't know if we'll cover today or tomorrow which one of those, but it turns out that this is something called the call stack. It means this function called 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 this one called this one called this one. And you can actually read a lot of information out of it. I know it looks overwhelming, but first of all, there's some line numbers in it. Even going beyond that, we'll explore that in a moment. But going beyond that, what you can read is that it's something to do with a state chart, something to do with executing an action, and probably in a state chart. That tells you a lot. This is not in some event somewhere, some event that's firing off. It's not just a startup for the whole model. It's in some sort of state chart action. Common action being like a transition. But more than that, we can go to something like this. This is one of the advantages of you being here. You're not afraid to see this. So watch this. Click that, and this is where it takes us to. See that? Who put that in? I did. I just did. So this is the offending line. From whence did that come? Well, it came from exactly where I placed it, right here. So it actually shows you, when you get a null pointer, this may frighten you, but if you go to the console, you will have all sorts of information that can give you clues as to where this is. And if you go click, often you can go click on one of these guys and it will be a happy camper. Now, sometimes things are not so happy. And the actual problem is occurring in code that's not in your model, but is in some Java library someone else wrote somewhere else. You don't even have the so-called source code. You don't even have the code for it. In which case, your program probably gave it something bad. So it's probably something that you gave it that screwed it up. It's like you wrote down your address wrong, your phone number wrong, and you gave it to some agency, and boom, it failed. So anyway, this is a notable feature of the situation, that you can have a lot of insight from seeing these things. But Jacqueline.
So sometimes AnyLogic will tell you when you have an error, and in this case it didn't. Why? Well, it told you now. It told you once you went through on the model, but sometimes it will tell you ahead of time, and I don't know if it was because it was so embedded in something that it wasn't affecting the build of the model, therefore it wasn't going to tell you until it tried to run it. But I don't. What's the difference?
Beautiful question. And oh man, the question is what not to tell you. So at a certain level, I could say that the answer to your question is because the compiler, the build, when I build the model using that build button up there, it's not smart enough to figure out that there's a problem with the model. All it's smart enough is to figure out that it doesn't understand what you are asking it to do. Okay? That's a very different thing. It can spot syntax errors, and it can spot crazy things like you're trying to add a person to a time or something like that. You're trying to add a person and a dog. It knows that's nonsensical. You're trying to multiply a pig by by a number or something like that. So it can spot silly things that are obviously nonsensical, obviously phrased improperly. But it's a bit like this. So you're a faculty member. So, if you had a student, maybe their first language is in English, and they give you an essay about computer science, right? You could spot a lot of problems potentially with that essay. You could help them with the grammar. You could spot things that are obvious. If they wrote in their paper "furious green idea" or what is it? What green ideas sleep furiously? You could say, well, wait, that doesn't make sense. Green ideas don't. How can you have a green idea and how can it sleep? So you could tell things that are obviously semantically meaningless and obviously syntactically off. But there's a lot of things about it that you couldn't evaluate. You couldn't evaluate, its plausibility in terms of what it's positing in the paper, right? Because it's outside your area. In a way, this is what we're dealing with, that it can understand a certain level of things, and it guards you against those sort of things, cases where it has no clue what you mean. But it cannot prevent certain types of errors. And this is where I was going to say I could also answer with this name. Alan Turing. And Alan Turing introduced the notion of what's called computability, and he proved essentially that it's impossible in general for a computer to spot ahead of time errors of this sort. There's a thing called the halting problem, and you cannot figure out ahead of time without running the program sort of what the problem is. So without running the simulation, there are certain types of things you cannot spot ahead of time. Because it's possible it will never get to this place, for example. So it can't find out ahead of time whether it could get to that place for sure without running the program itself, without simulating it. So here, this is a very important point. You cannot rely on the build to catch most bugs. You can rely on the build to catch things that are obvious, that are more obvious, coarser grained, and that are very important in terms of kind of it has no clue what you mean. But if it knows what you mean, it's going to do it, whether you want it to or not. It's going to do exactly what you told it to do. And sometimes that's not what you want it to do, but it's what you told it to do, and it's going to do it. Yeah?
I'm curious, each of these lines are not necessarily equivalent to one bug. So
No.
it's the case sometimes that you might fix one thing and it might eliminate all the lines.
Well, these lines are actually all lines that provide clues as to where there's one problem, this null pointer exception. All of these provide contextual cues of successively finer grained character to point you to where this particular problem occurred. These are actually, in contrast to the problems window, which shows several different things often, these are just all pointing to successively kind of more narrow places where this problem lives. And
There's
basically,
ripples in the pond.
they're kind of successively narrower ripples. And this is...
Changing one thing, you might eliminate all of them. It's just one.
Oh yeah, no, this is just the context where it occurred. It's kind of like you could ask me, where did you get, where did you get your flat tire? And I'd say, well, I was driving down that cloverleaf onto the highway just off of Highway 16, and it's the area of Highway 16 south of Saskatoon, and and successively larger layers of sort of context. This is kind of localizing the error. And basically, the error could have originated with any of these layers, actually. I might have hit that nail at any place kind of in that area. But like this called this, called this, called this. It may have told it. When I say call, it like said, do this thing, and it called off to it, and do that, and it's just successive layers making requests of each other, and somewhere along the way, something was off because then the error occurred here. But it may have been this guy who passed the wrong information out. In this case, the issue was all right here.
So, is it
Yeah.
from the bottom up then in succession or top down?
This is the outermost, this is the innermost. This is the part that's sort of closest. And I actually have some slides on this later. But this is what's called an exception.
Okay.
An exception is thrown. And maybe just because I want to be very pragmatic in what I show you. I mean, I was actually unsure about how much I'd show you on functions. But maybe I'll talk about this, okay? Just because we're right on. Yeah. Oh boy, I'd love to talk about it. Oh boy. Okay, I'll come back to this. But basically, there are all these functions behind the scenes or that we put into our model. See all these functions here? We'll sometimes put them into a model. Remember, we created a function today. Do you remember that? But Java also has all these functions built in, and in general they're called methods if they're associated with, you call them on an object. You call them this, do that, or you know, person P dot you know, get connections number. That's a method. It's a function that's computed on an object. Okay, and these methods are sort of key. These functions are key in how things work. And you know, one will often request some work of the next, of the next, of the next. Kind of like if you were a general contractor on your house, say to remove asbestos. Well, believe me, don't even get me into it. But if you're a general contractor, they might subcontract to a concrete person, and that concrete person might subcontract to a structural concrete repair person who subcontracts to someone whose expertise is injecting polyurethane into your wall to fix some cracks, which even right now are outgassing in my home. And so there's this sort of successive level of requests, right? And if something goes wrong, even with that last person, you might hear about it eventually, right?
Yeah.
You might eventually hear, like, he never paid me, you know, or he screwed me over because he stopped me from working when I wanted to work. He ate my float, and therefore he caused me to, you know, to lose another job, and therefore he owes me money because he's not paying. Buddy, you better pay. These things happen. And so it is with methods. Methods call each other, and then something can go wrong along the way down here, and it ripples up. It ripples up all to the user, and you say, null pointer exception. And you say, well, what do I care about a null pointer exception? But ultimately, he who pays the piper calls the tune.
Either way, you owe it money.
Either way, somebody.
There's a lien on your house.
Yeah.
That's right. That's you know it. Yeah. So basically, we'll have one method call another. So there might be a perform birth method, and this method might call add population, for example. And then it might call establish offspring connections based on the mother's connections. It might call establish offspring location based on mother's location. Then I might call add to the children collection to add this child into the set of children of this mother. So here, perform birth calls this, and it runs for some time, and then it will return to perform birth. It's kind of like the concrete contractor who asks the structural guy to come in, and the structural guy brings the guy just the polyurethane, and that guy's there for a couple hours, and then he's gone. And now it's back to the work of the structural contractor.
In the one you just made,
Yeah.
the null pointer exception that you just
Yeah.
made, with all the red,
Yeah,
when we read that one,
yeah.
oh, it's not in the PowerPoint though, it's out in,
No, it's not, but it's like one calling another, calling another.
so in that text, it's
This-
saying it called the file, and then it said to simulate, and then it said to run the experiment, like.
That's
what
right.
it's telling you to do.
That's right. So here's like experiment, experiment run, and then it did something called A, and it called start on the engine, and then it called start on main, and it called start on person, and then it said start on the state chart, and then the state chart said, bad thing happened. The contractors aren't quite that vocal. Well, it can be, but they tend to use different language. So, this could call this, could call this. That's the picture here. Is that okay? Okay, so this is what's called a call graph. Now let's talk about this, because this leads to something called a call stack. And this, ladies and gentlemen, is a call stack. That is a call stack. Each time there's a call, it gets one taller, one taller, one taller. It's like one more layer of context. One more layer of context, okay? One function calls another, and it needs to remember where to go back to. So this guy calls this guy, and this guy might call another guy, another guy. And each one needs to remember where to go back to. It's like when it's done. It's kind of like the polyurethane guy's been brought in there by the concrete structural repair guy, and he does his work, and he tells the structural guy, okay, I'm done, now you can do yours. You put on the angle brackets. And the structural guy can now do his job, finish his job. And then once he's finished his job, the folks who are going to cut the big hole in the floor do their job. I think Cheryl had a big hole in her floor one time too.
I had to cut my own hole up.
Oh, you did? Okay, well. You don't do that service for others, do you? I'd hire you in an instant. So here we have this call stack here. So one function calls another, and what's happening each time is it's getting sort of deeper and deeper, and it's each time it's sort of staving away some additional information. And you'll encounter this in error messages. You'll also encounter if you try to debug in AnyLogic. So this can call this, and while this is running, these two are still waiting for it to return so they can continue. So then that can continue to do its job. And they have variables. In each layer, they have variables. Like this guy's for variables, this body's for variables, this one. And they live on this stack. And they have different, they may even have the same name, but they don't know about each other. This guy calls this guy. This guy doesn't care what this guy's variables are internally are called. And these guys' variables live, and this guy calls this guy, and he does his thing, and then it returns here, and then it returns there. And that's exactly what we see here. That's exactly what we see. That's all this is. This guy called that guy, 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 called this guy. And normally, like this run guy down here, he doesn't want to care about anything that's going on up here. But when something goes wrong, then it starts getting messy. Like I don't really care about who's doing the polyurethane as long as the GC delivers on his project on time, on budget, and does so with within the agreed upon terms. But then I hear something goes wrong. I hear something goes wrong with that polyurethane guy, and he was squirting water in instead of polyurethane. Or if he screwed up the thing for the concrete structural guy, I'm going to hear. And so it is with an exception. This is like when things don't go good, then I hear. Right? Okay. Yeah. Bad news. Okay, so I don't think I'm going to go into this, but just be aware that when one thing calls another, they don't have to worry about all the internals of what they're calling. They're just making a request. It's just like I ask for a service to be done, and it gets done. I don't have to worry about all the internals there. It's like I'm going to FedEx, I want to ship a package to Toronto, and I don't have to care what the name of the person is behind the counter, who's flying the jet to Toronto. That's all their business. As long as they get it to me, get it to Toronto by the agreed upon time, I will pay them, and both sides will be happy. Okay? And it's like that with calling another method. I could go into this more, and for some other times I will, but suffice it to say there's not much. I don't think we have the time or the need to go into it right now. Okay. Right. Okay. I think I'm going to let's talk about exceptions then. So these exceptions that we're talking about. Oops. Hey, come on. Java statements. Yes. Back to exceptions. So things go wrong, and frequently we want a way to signal. And what happens is it gets signaled, and then along the way we can catch it. It actually could be caught at any point. Any point along this way, it could have been caught. Someone could have caught it. Someone could have. It's like I could have a contract with subcontractors where basically they said, look, they take care of all the legal issues. Okay, they guaranteed all the risks. I don't have to bear the risk, and therefore I pay more to them. They'll handle any subcontracting issue. I wish it were so, but it's not. But you could have that in principle, that you could have a contract which shields the owner from any lien on their house for a higher price that I'd pay. And so it is with along the way, we could do something that's called a catch. We could catch an exception. And your code, ladies and gentlemen, may sometimes need to catch an exception. I'll show you a case where this is. So we might do something like this. To catch an exception, we'll do try this thing, and if an exception is thrown, we'll do something. So this is what's called catching the exception. And that means the exception won't just go from here and ripple all the way out to the user. Instead, it will be caught. This exception will be caught right here. So it sort of catches these bad things happening. So this is a case, for example, where I had a model that is to open a PyEC file. And this was reading, does anyone know PyEC here? Okay, it's a social network analysis tool. It's a tool written by someone else. It's a tool, in fact, it's a free tool. I don't know, is it open source? I don't know if it's open source. I don't think so. It's just distributed for free.
But
So
also from Russia.
yeah, Czechoslovakia or something. Yeah, somewhere in Eastern Europe. PAJEK. PyEC.
It's a proper name.
Yeah. So here, ladies and gentlemen, this code was opening up the PyEC file, and then it was trying to parse it. It was trying to get, for example, integers. So the edges in PyEC files are said to go from a node to a node. And so here I'm getting sort of getting the two edges, I think, in the node, right, and the two nodes associated with an edge. And the problem is that this thing could say, like, I can't, they're not numbers. They're not numbers. Maybe this PyEC file is screwed up, and instead of having a node that says, you know, this edge goes from 1 to 2, it says it goes from Nate to Foo, or something like that, in which case it can't read as a number. And so this is kind of what I'd like to do. I'd like to get a number and connect them together. See, it's connect to, that's in AnyLogic, connects two nodes together. But instead, it might throw an exception because it doesn't know what to make of whatever's there. In which case I have to handle it. In which case I say, could not parse this line. I can't parse it. I can't make sense of it. Sorry. And we're then a happy camper. So this is what's called a try-catch block. In AnyLogic, we used to have to do these more. Like when you have to open a file, you would put this around it, or write to a file, you could put this around it so that if it couldn't find the file, it would, you know, we could print out a nice message for the user instead of having something that says pops up in front of them, like this most rude thing that popped up here, right? Instead of doing that, we want to be able to, instead of this sort of thing, we want to be able to print a nice message, like, oh, I couldn't find the file, whatever. Couldn't find the file, myfile.xls. But these days, AnyLogic handles more and more of this, but you'll occasionally see these try-catch things. And if you get these errors, the main thing I wanted you to know is how you can start to debug them, how you can start to clue into from whence they come, and how you can use these links. And it's the links at the top that you want. If I click on this thing, if I click on this bottom one, I'm not going to be, or this one, I'm not going to be so clued in. Like, this doesn't mean a lot to me, except that it's something to do with an infection state chart. I know it's occurred something to do with the state chart. This guy's just going to tell me, go run the model. That's not very helpful. But this innermost guy here, it's actually, hey, come on. I thought we saw it before. This guy here, 214, right? Hey, why isn't it? Oh, man, come on. Close that up. There we go. 214. This is the problem. It's that one. So if you get a null pointer exception, you can use this to zero in. And this is the call stack. This, call this, call this, call this, call this, call this. And that's how things work. You call something, it may call 3 more things until it can come back to you. Call each of them in turn. Boom, 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 boom. Make a request, just like those concrete contractors. Just be aware, you can use a try statement. A try statement, like this guy, to handle bad things that happen. Is that helpful? Okay. Hopefully you won't need that much, but you should be aware it does exist, and exceptions shouldn't make you fear. You can go in and dig down into them. Okay, time is a fleeting, so I want to cover some more stuff. Any questions on that though before I go on? No? Okay. Okay, right. Okay, I'm just going here. I think I'll skip. These are about methods. I don't think I'll go through these in any great detail this year. There are places where you will find me online, expound upon them. Let's talk about classes, objects, and references. What's a class? So all these things we're adding: person, grocery store, convenience store, main, in fact. These are all classes. There's a class, again, it describes like personhood, convenience store hood, grocery store hood. It describes sort of what it means to be a grocery store. Now, when would you create a class for, say, well, okay, so we have classes, and then we have instances of a class. So we have particular people. Those are what we call instances of the class, person, particular people, okay? Now the class is kind of, what defines it in many ways is the behavior and the data associated with it. So a person has an income, they have maybe an education level, they have a state with respect to infection and care seeking, another state, a state chart associated with care seeking. We have some behavior associated with those states. That kind of defines the class, tells what it does. And in general it has some fields, what we call fields and methods, but in terms of AnyLogic, we think of it as being defined by its behavior and the information it maintains, this class. And then each instance of the class will have different particulars, right? Each instance may have a different income, a different state that they're in right now. So person 1, person 2, person 3. Does that make sense? We call those instances of a class. We also call them objects. And that's different from a class. A class is sort of personhood. An object is a particular instance, a particular sort of person in this case. Okay? And this is from a paradigm called object-oriented programming. And Scott actually mentioned it the other day. He said a lot of these simulation packages are going to object-oriented programming, even though they're not agent-based. And agent-based modeling is defined. It's perhaps most. I think of it as actually almost being defined by use of object-oriented programming for simulation, where the actors are objects. Okay, so within this context, we have a class. It's kind of like a cookie cutter, and then you use it to make many cookies, right? It's kind of the shape of those cookies, and you use it to make many particular cookies. Those are the particular people, say, from an agent class. So lots of these things we've been using are classes. These are in Java, they're called classes. Now, for some of them, there's only one of them, an instance at any one time. Which of these has only one instance, only one object at any one time? Main. And typically the simulation only has one of it too. But persons typically have many. Or agents. And it turns out all persons are can be agents. All grocery stores are agents. All convenience stores are agents. And in general, you add what are called agent classes in AnyLogic. And some of you may have wondered, like, why Dylan could say something was an agent in AnyLogic. Well, it's because both a convenience store and a grocery store were agents. And in fact, when you go to add something in here, file new agent type, that's an agent. And this will get us to a lecture we'll have tomorrow. So what do you do with these objects? What do you do with these instances? Yeah?
Sorry, so what's the simulation class?
Simulation class, it's a class and it only has one instance. It defines how to perform a simulation. And as a single instance, it's the running simulation. A little bit confusing, but that's how it is. So what do you do with objects? What do you do with these instances? Well, you can read things from them, like their income. You could set their income. You could call their methods. You can ask, give me your information on whether you're infected. And AnyLogic generally takes care of creating it. So we could say, like, person, get their connections number. A person, get me a string representing you. Person, get me who your connections are. Or maybe connect you to a certain person, or disconnect you from a certain person in your network. These are things you can do with a reference to an agent. Agents support all these things you can do with them, and these are some of them here. So these instances we can use them in very useful ways. And we saw how we could do this as expressions before. If I have a reference to a person, I can ask for the connected agent, the third connected agent, and convert it to a string, for example. Okay, yes, question?
I think that the most efficient way to find that information in terms of the capabilities of AnyLogic.
What's the most efficient way?
Like, would help me,
Yeah.
Because I've used
Sure.
help quite a bit, and then it'll pop something up, and it's like, oh, okay, well, I didn't realize that existed. So I guess I'm asking the question, what do
Right.
you think
Yeah.
the best reference source is for those different
Yeah.
capabilities?
So I wish I could be the bearer of good tidings. But I'll tell you, but first of all, I really value this question. It's a very practical question, and I stand remiss for not addressing it. But I'd like to tell you what I do. Okay, there's two primary sources that I have for information. The first primary source is autocomplete, and the information provided by autocomplete.
That's pretty cool.
And
Space or control space.
yeah. So let's go back and clean up this this guy here. Let's go back to this guy. And here I have this guy, right? And there's no question that by doing mother dot whatever, I can see all these things that I can get from it. I can get it, I can get the main associated with it. I could get the name of the state. I could get railway networks associated with it. I could ask if it's in a state. And you notice for each of these, there's this documentation that pops up. That's not to be minimized. I mean, that's pretty useful. So this is actually a major first line of kind of use for me, and I can find out a lot through that. But truth is, I will often go further. By the way, you notice for some of these, there's you can go and you can scroll down and see this. So not too bad there, but there's better. There's books like the Big Book of AnyLogic and so on. I don't tend to do them. I can search online, but sometimes I'll go to the AnyLogic help here. And I'll tell you I personally strongly dislike AnyLogic help. I think AnyLogic help is really substandard.
Yeah.
And I think it's really hurting where it needs to be better. I will often find searching online gets me closer to the help thing that I want, but a disconcerting number of times I search online for it, I get my own video. I say, what does he know? Don't listen to that. That guy doesn't know anything about this. It's happened in class before, and it's most embarrassing, especially when my voice starts playing. Yeah, but actually, this is a useful thing here. They may have reorganized them, just looking here. I mean, they have some good things in here. These tutorials are okay, and there's some basic stuff in here. But if I really want to know about some of the nuts and bolts, really what I tend to go to like this thing, the API reference, and go look at the engine, and I can go find things in here that are quite detailed and that provide me with a lot more information about what's going on than I can in just kind of their normal help menu. And it's a little bit overwhelming potentially, but I find this is like my go-to place. If I really got to know, I tend to go here. And so that's kind of my fallback resource.
And I will say, to their credit, if you email them under Get Support,
Yes.
they will respond.
Yeah.
And in that instance, I think the farther along you are, and the more context you can give
That's
them
right.
with sending them your model.
Sending the model.
Then the
That's
better
right.
off they're able to help you, because otherwise they'll give you some random, use my predicate, and you're like, what? I mean, if you don't have enough knowledge.
That's right. But really, we're also hoping to really, with this community, take it to another level, because some people are asking questions on LinkedIn site, but LinkedIn site has a bunch of weird commercial tie-ins, and it's kind of weird, and there's people promoting themselves and stuff. And this is one of the reasons we're setting up this community site. The other reason is, I actually do really believe that health has a lot of distinctive features that are quite different than if you're just doing manufacturing or something. And if someone comes in and is asking a question who's from health background, it will clue us into what language they might understand, and it will clue us into what they're probably trying to do roughly. There'll be often a lot of contextual help in the various elves providing advice, right? And sometimes Santa may be on there. So I think we're hoping that site will be a place where questions can get asked as well, and where TAs might secure certain good visibility by being able to answer questions on there. So that's okay. So thanks. Okay, so let's talk a little bit more. So ladies and gentlemen, this is class and object, and there are some things that are confusingly called static things that are characteristics of the class and not the objects, not the particular instances. We saw this yesterday. Do you remember that? Where there was one thing, remember infective, the meaning of infective? That's something about the class. It doesn't vary by agent. It's something for the class as a whole. Agents differ in their incomes. They differ in what state they're in. They differ in terms of certain characteristics, but they're all going to share what it means, like the name of the state by which they're infective, that designation. They're going to all share. So we call this a static thing. And you can actually associate these so-called static variables. And in AnyLogic, you can mark certain functions as static, meaning they don't depend on a certain instance of the class. They're for the class as a whole, like a map from age to people's risk of starting to smoke, or their incidence rate for smoking, their uptake rate. Very, very common that you might want to do something like that. You don't have to do it, but it's a good thing. Or you might have a variable that's a constant. It's just a constant you use in your model, and it doesn't have to be maintained on a per-person basis. So you associate with what's called a static item with the class. This is not something you particularly have to worry about a lot, but if you're building these models a lot, it's a good thing to know about, that there are these things called static, and occasionally you'll see it mentioned. It's a very confusing term. When we said yesterday variables hold references, it was references to instances of a class, to particular people And one reference that you can hold is null, which means it doesn't refer to anything. And that's where we saw that null reference exception. We tried to get an income out of something which pointed to nothing, no particular person. It's like me saying, you must tell me the last name of the director of the school of public health. And Cheryl, could throw a null pointer exception. She could tell me to buck off, or something. So in any case, sometimes we have these designations that are called references to instances, and sometimes they can be the designated reference null, and in which case they don't refer to anything. Okay, I think that's all I'm going to present on that today. Let's just see if there's anything else that I think is really critical for today. I guess I will just say that in general, when we have quantities like variables defined in our model, or parameters in our model, they are associated with a certain so-called type. These types designate what sort of information they can hold. Remember, we've seen this before: Boolean, double, or a reference to a person, a reference to a grocery store, or what have you, a reference to a string. These are what are called the types of a given quantity, and they kind of delineate the set of things which it can possibly hold. So, there's a bunch of ones built into Java: booleans, doubles, shorts, ints, chars, bytes, longs, floats. And then there's non-primitive types. These are like references to classes. And why do we use types? Well, it's to prevent common errors. It's to prevent something silly like there's a deer in the model and there's a person, and we assign the deer to the person, or something like that. But sometimes we have to cast. We have to convert between types, and in this case, we might convert like a double, an integer to a double. Do you remember that? We had that double thing. Remember, we had like maybe 4, and then we might have we wouldn't do it with that. But if we had variable a, we might do double like this. And that means basically convert it to a double precision value. Maybe this is an integer. I'll call it I, because we typically use those to denote ints. And this will convert it. So maybe this is 4, and now after this, so maybe this is 4. And maybe this whole thing is what? 4.0. Something like that. And that could be important if we were dividing 3 by this. If we didn't do that, if we just divided by I, what would we get? 0. Because 4 goes 0 times into 3. But if we do 3 divided by 4.0, it's 0.75. Okay. Types are important. Types are common. Types are good to know about. And in general, you will need to declare types for lots of things you put into the model, and you'll need to declare them for functions, as we'll learn next time, that take values and return values. Okay, that's all we're going to cover today. I think people have to get out to the bus, and we'll see you tomorrow. I welcome any questions people may wish to ask now, though.